For ripples on water and sound waves in air, what evidence is there that these are waves travelling, not the water or air itself? So there's a couple of observations that we can use as evidence that this is actually wave motion and not the bulk transfer of material from one place to another. So let's take a look at this evidence. So to start with, we could say number one, ripples on water radiate outwards, just like we have in this little picture down here. These ripples are radiating outwards from the center spot where we disturbed the water. Maybe we dropped a pebble in. And those waves move outwards. Now, if the water itself was moving outwards, then we wouldn't be left with any water in the middle. It would disappear. We would have a hole. And that's obviously not the case. So the first thing we can say is that ripples on water radiate outwards in circles. And we can say that if the water itself was moving, we would be left with no water in the middle. Or in the center, which is evidently not the case. So another good piece of evidence for these being waves and that the water is passing on the energy of a wave, but the water particles themselves are not moving outwards. The second bit of evidence that we can use, again with water waves, is that if we were to put a floating object on here, then what would its motion look like? And as the waves pass through it, that object, that floating cork, would be going up and down as the waves pass through it. The object won't be carried along with the ripples. So we can say a floating object on the water, oscillates. Oscillates, that's a good keyword to use in waves. You can say vibrates as well, but oscillates is probably better here. Floating object on the water oscillates up and down, perpendicular, so at right angles, to the direction, to the ripple's direction, Okay, so the ripples are going out from the center, but the cork or whatever's floating there is going to be going up and down. So it's not carried along with the wave. It is not carried along with the ripples. Now you might say, well, hang on a minute, isn't it the case with a surfer that they get carried along with the wave? And that is true, but in that case the surfer is actually skimming on the surface of the water, and gravity is helping the surfer to fall down the wave. So if that's your wave, then the force of gravity is actually making that surfer skim down or slide down the wave as the wave is moving forward. So in that respect, they are moving with the wave. But if you had a floating object, that floating object would just move up and down as the wave passed through it. Okay. The third thing we can say, number 3, when we think about sound traveling through air, it makes objects vibrate back and forth. So for example, your eardrum. Now, if you're at a loud concert, let's say, and obviously you'd be wearing ear protection because it can be very dangerous, loud noises and loud volumes of sound for our eardrums. Do you feel a wind from the speakers? Well, not unless they've got lots of fans on the stage blowing you away. No, you wouldn't. So that's another bit of evidence which really says that even though you have very loud sound levels here, you're not feeling this wind, this movement of air. You're feeling oscillations. You're feeling your, in fact, sometimes you can actually feel your body vibrating with the sound waves as they hit you. So that's another good piece of evidence which is really saying that this is wave motion. So we can say when sound travels through air, it makes objects vibrate back and forth. We could say e.g. eardrums. Eardrums will do that. That's how we hear. And we don't feel a wind. We don't feel a wind when we hear a loud noise. Okay, so I hope that helps and I hope that makes sense, and I look forward to seeing you in the next flashcard.